Hello everyone. Today we are solving this problem, find the most commutative subsequence. So before discussing the problem statement, let us first understand what is a subsequence. So suppose we have a sequence or an array of integers or maybe characters. Let us say that we have this array. Now formally speaking, a subsequence is formed by removing or erasing few elements from this array or sequence, possibly zero elements, and whatever we are left with is known as a subsequence. That is, if I erase any elements, suppose this and this, then we are left with 2, 4, 1, and this is a subsequence. I like to say that we pick few elements from the given sequence and we place them without changing their order, then what we have is known as subsequence. Suppose I choose 2, 4 and 1. So 2, 4 and 1, and see, I have not changed their relative order, that is 2 is indeed before 4 and 1 in my subsequence, and so is the case for 4 and 1. Therefore this is a subsequence. So we are done with the subsequence part, and now let us understand this question. So in this question we are given an array of integers and another integer k, and we are required to find the most commutative subsequence. Now what is the meaning of most commutative? Suppose we have two subsequences of equal length. Suppose we have 3, 4, 5 and 1, and another subsequence 3, 4, 6 and 4. So out of these two subsequences, and as you can see that the lengths of both the subsequences are same, suppose that this is subsequence A and this is subsequence B. Now if I ask you which is the most commutative one, the one which has a smaller integer at the first position where their values differ is known as the most commutative subsequence. So in this case we can see that the first position from the left where the integers differ is this position, that is the third position or index 2, and the subsequence which has a smaller integer here is subsequence A, and therefore we can say that this subsequence is much more commutative than B. So if we are given an array, suppose this array, then what is going to be the most commutative subsequence if we are required to find the most commutative subsequence of length 4? Well, there are various possible subsequences of length 4, but the most commutative one is something you should try to guess. So the most commutative subsequence is actually 1, 150 and 150. Now, there is a possibility that some of you might have thought that this should be the most commutative subsequence, but if I write them, then what is the first position where their integers differ? Well, the first position is position 1 or index 0, and which subsequence has a smaller integer at this position? This subsequence B. And therefore I can say that 1, 150 and 150, that is this subsequence, is the most commutative subsequence present inside this given array. And do remember that we cannot do or form 1, 2, 3, 4 from this given array, because as we know that subsequence means that we need to maintain the relative order of elements. So I cannot bring this one before 2, 3 and 4. So this is our answer for this case. Now the only things that left is to know how to reach to this answer. So the most intuitive thing we can think of is actually using or keeping the smallest integer at the leftmost position. As we saw in the previous example that the most commutative subsequence actually started from an integer which was the smallest. And this definitely makes sense. But what if instead of 2 we had 1 here? In that case we had these two subsequences 1, 3, 4, 5 and another subsequence 1, 150, 150. Well, the most commutative one in that case would be 1, 3, 4 and 5. Although it is not the most commutative subsequence in this whole sequence, because if you can understand this clearly, that if we have 1 here, in that case we have 1, 150 and then 150 as the most commutative subsequence. If we have 1 here. That is, I am striving to get the smallest possible integers in all the positions. I could have placed 100 here, but the thing is that I have a smaller integer to place here which is 50 at the third position, therefore I place this, and then I am left with only one integer, and I am assuming that the length of the subsequence that is required, that is k, is equal to 4, therefore this is the most commutative subsequence if I am not mistaken in this sequence. So now I want you to pause the video and think for a minute how this problem can be solved. So the first idea that may come to your mind is to actually find the smallest integer in the array and use it as the first element. in this case we have this element as the smallest element. So this is our first element, and after this I'll try to find the next smallest number in the right subarray. Now right is because we cannot place these elements after 1, and therefore we look in the right subarray and we see that 50 is the smallest element, so we place it. And again we look at the right subarray of 50 and there is 150 only, so we have to place this because it is the smallest element in this subarray of length 1. And here's the problem: k is actually equals to 4. That is, we needed a subsequence whose length is equal to 4. But as we can see that this subsequence has a length of 3 only, so this idea fails. Now why this idea fails? Because when we chose 50 as our second element, then the number of elements that were actually required by us to make this subsequence of length 4 were 2. But on the right of 50 we have only one element, so when we chose 50 it was impossible for us to actually form a subsequence of length 4. So one thing you can do is to restrict your search by some elements. So first we chose 1 and then we are searching in the right subarray, and the current element that we are trying to find is going to be the second element of this subsequence, and therefore it is necessary to leave at least two elements from the right side of this subarray, because then these two elements can be used to form the rest of the elements of the subsequence, and therefore I'll restrict my search from first element after the last found element, that is from here, to actually leaving the last two elements because those elements are going to be placed here. And then my scope of search will be only this array, and this has only one element, so it is naturally the smallest element, so 100. And same goes for 50. Again this time my scope of search is from one element after the last found element, which is 100, that is from here, to leaving one element for the last part, which is 150, and therefore placing 50 and then 150. Now this method I think will work. I thought of this method just now, but there is a better way to solve this problem, and that method is going to solve this problem in time complexity of order of n, because we will require only one search or one pass through the array. So to solve this problem in one pass, we require a stack. So how we are going to do things, let us see that. So we will start by actually pushing the elements. Suppose that initially we are at 2 and we push 2 in the stack, then we come at 3. Now 3 is greater than 2, so definitely there is no point in actually removing this element. So I'll place 3. Then I'll go to the next element, and suppose that I encountered an element which is smaller. Then in that case I'm going to pop this element and or remove this element, because I know a better candidate for this location is here. Suppose that at one time I encountered one, and suppose that these elements are not here. So if I encountered one, I am going to remove this element and I'll place 1 here. But again I can see that 1 is in fact a better candidate to be placed at the first location as well. So I'm going to remove this as well and place 1 here. But there is one more catch to this problem, and that is the same problem that we just saw when we tried to solve this problem using another method. So we'll encounter that problem here also. So now let us start and see the working of the solution, and till then you should try to understand where this method might fail if we don't put a condition. So I start by actually pushing 2 in my stack, then I move to the next element 3, which is greater, therefore I'll do nothing and just put this element inside my stack. Again I go to the next element, which is 4, push it, 5, push it. Currently we are fine because the size of our stack is 4 and this is the length of the subsequence also that we need. Again we go to the next element. Now we can see that 1 is definitely the better candidate and it is smaller than 5. Therefore I am going to pop 5. It is smaller than 4 and then 3 and then 2, and then there is no element left. So I am going to push 1 in the stack finally. Then I see 100. 100 is greater, therefore I'll push 100. And here's the thing. Now I see that 50 is smaller than 100. And now if I actually removed 100 or popped this element 100, then I'll have 1 and then 50, and in the last I'll have 150, and that means that the length will be actually 3 of the subsequence, while I required a length of 4. So this is the main point or the learning point from this question, that before popping the elements from the stack, we are going to check if it is possible to do so by actually counting the remaining options that we have in the given array and by seeing how many elements are there in our stack. So we were at 100, we pushed 100 and then we went to 50. Now, yes, 50 is smaller, but how many elements are there in our stack? Two elements. How many elements that are left? Well, there are two elements that are left because we have not pushed 50 yet and we have not decided what to do with it. So we have two elements left here and two elements left here. So 2 plus 2 is equal to 4. So this means that I cannot pop this element. Suppose that we have another element here. Suppose that we had a 10 here and then we encountered 50. Now can I do the popping? Well, 50 is smaller than 100 and currently we have 3 elements left and 2 elements in the stack. So 2 plus 3, that is a length of 5. So 2 elements are already decided in a way and there are 3 more options for me. So definitely it is plausible to actually pop this element, because if I do so, then still I'll be left with two more options, and being left with two more options means that I'll satisfy the condition of forming the competitive subsequence of length 4. And therefore the condition that we are going to make is this, that if the current element is smaller than the topmost element in the stack, and if on popping length of the stack plus number of remaining elements is greater than k, only in that case I can pop elements. So let us continue with the working of our solution. So we come at 50 and we see that even though 50 is smaller than 100, I cannot pop 100 and therefore I'll place 50 here and then I'll move to the next element. We have only one element left. This element is greater than 50 and therefore we are going to push it as it is. So this is our most competitive subsequence and we found it only in one pass, although a reverse pass is also required inside our stack, but in that case also the time complexity is only order of n, because these popping elements are not going to be popped again and again. One element is going to be popped at most once, after that it will be out of the array. So this is the solution for this problem and now you should try to code it yourself. And now let us code this problem. So the first thing that we need is a stack, and rather than using a stack I am going to use a vector while doing the same operations as we do in stack. I'll name this vector as stack. Then I need an integer n which is equal to size of the nums. Then I'm going to parse the given array, and now the three conditions. I need to see if the current stack has some value or not. So if stack is not empty and current element is actually less than the top element of the stack, that is nums of I is smaller than the top element, that is this element of the stack, and the very important third condition that I talked about, that the number of elements that are present in the stack plus the number of elements that we are left with, and that is going to be equal to n, that is the size of the array, minus current index I. Now this thing must be greater than k. So let me write it here as this. Now if these three conditions are satisfied, only then I'm going to pop the last element, that is nums dot pop. Now if the size of the stack is less than k, only then I'm going to push the element, because I need to return the subsequence of size k. So if nums dot size is less than k, only then I'm going to push the current element, which is nums of I. And okay, I'm sorry, here I need to write stack, here I need to write stack, and here I need to write stack as well. I hope that there's no more problem. And yes, here also I need to write stack. Yes, only then I'm going to push it, and finally I'm going to return our stack. So this is the solution. And one last thing, that what we are using is actually a vector and not a stack. So here we'll have pop back. Now I'll run the code, accepted, submit, accepted. So this was the solution to actually solve this problem, and I hope you liked the video. And now I'll see you in the next video. Thank you.